All right, I'm back to talk about solving systems more. This will be a shorter video because I just want to talk about one problem, okay? This is a unique type of word problem that still has to do with solving systems, but that typically gives students a little bit of trouble, so I wanted to make sure I gave it its own video, okay? The reason this problem is difficult is because you need to understand the distance formula. You need to understand that distance is calculated as rate times time, right? The simplest example of this is if you get in your car and you go at a rate of 20 miles an hour for a time of 2 hours, you'll go 40 miles total distance. So let's use this to properly set up this equation, right? So if we travel a total of 700 miles each way, the distance isn't changing, but the rate at which I'm traveling and the time it takes may change, okay? The trip there is with the wind. So the rate is going to be a combination of what is the speed the plane is going at, like what are its engines powered up to, and then that tailwind gives it a bit of a boost. But on the way back, going into the wind, the rate will be the difference between the speed of the plane fighting against the speed of the wind. So what does that look like? Looks like 700 miles. On the way there, we're traveling at a rate that is a combination of the plane speed plus the wind speed. And if we're traveling at that rate, which is unknown, right, the total rate, it takes 7 hours of time. Now, the way back, the distance has not changed. I'm still traveling 700 miles, right? What has changed is that now I might be powering up the plane to a certain speed, but when I'm fighting against the wind, I'm not really going to be traveling that fast. And because of that, it takes 14 hours, twice the time. Right, now the approach here is this. You could multiply in here and then try to solve through elimination, and that would work. However, I think to make your life easier, you could notice that, well, if I can get rid of this, the 7 and the 14, then I'll have a positive and a negative that will just cancel. So why don't I go ahead and divide both sides by 7. And here, divide both sides by 14. So basically, I'm removing the time so that I can find the rate. So here, what I'm learning is that the rate of the plane plus the wind is 100 miles per hour, right? Distance divided by time would be rate. What I'm learning here is that the speed of the plane minus the speed of the wind is going to be 50, right? 50 times 10 would be 500. 50 times 4 would be 200. That's 700. Now be careful when you add these together with your process here, right? When I add these together, yes, the W's cancel and I get 2p. And I feel like it's a common occurrence that students will do 100 minus 50. But that's not what I want to do. What I want to do is add them together to get 150. So if the speed of the, doubling the speed of the plane is 150, then the individual speed of the plane is just 75 miles an hour. I'm not entirely sure that that's physically possible to only go that fast and get airlift, but it's just a word problem. Now I need to plug this value back in, so that I can solve for the speed of the wind. The plane plus the wind is 100, so that makes me think 75 plus 25. Now let me check my work. Is 75 minus 25 50? It sure is. So the speed of the wind is 25 miles per hour. All right, this is just one example, but I wanted to make sure that I made a separate video just for this one because it does give people a hard time. And hopefully, this is something you can come back to and it will help.